We'll go over some more examples on evaluating limits. And first one here, evaluate the limit as x approaches 0 of e to the power x. So just get to substitute where there is x, we put a 0, and that is going to give us a 1. Second one, evaluate the limit as x approaches 0 for tan x over x. Well, when you're talking about trig limits, we need to know two special ones. The limit as x approaches 0 of the sine of x divided by x, we need to know that this is a 1. And the limit as x approaches 0 of 1 minus cosine of x divided by x, we need to know that this is a 0. So I'm going to write this as the limit as x approaches 0 of tan of x, now multiplied by 1 over x. And this will give us limit as x approaches 0. Tan, we know that that is sine of x divided by cosine of x multiplied by 1 over x. So this will give us limit as x approaches 0. I'm going to make sure that x is down the scene so that we use this special limit which is there. So that is going to be the sine of x divided by x multiplied by 1 over cosine now comes down 1. Now I can split by the rule of limits. This can be written as the limit as x approaches 0 of sine of x divided by x multiplied by the limit as x approaches 0 of 1 divided by cosine of x. And we know that this one is always equal to a 1. Now if we get to substitute where there is x, we put a 0. Cosine of 0 is a 1. 1 over 1 is a 1. So this limit is going to give us a 1. The next one, we have got the limit as x approaches 0 of sine squared x divided by x. So this one we can say this is the limit as x approaches 0 of sine x multiplied by sine x. The x will just be under one of them. So this is sine squared. That's why we've split it like that. So this will give us a limit as x approaches 0 of sine of x, and also the limit as x approaches 0 of sine of x divided by x. We know that if we get to substitute direct 0 here, the sine of 0 is a 0. We can check that from a sine graph. And we know that this is a special limit, sine as x approaches 0 of sine of, limit as x approaches 0 of sine of x over x, that is also a 0, and that will give us a 0. We could as well taken it in another way. Limit as x approaches 0, sine of x, we can write it as 1 minus cosine squared x divided by x, and that will give us limit as x approaches 0. We have got a difference of two squares. 1 is the same as 1 square, so that will be 1 minus cos x, and then 1 plus cos x, and then divided by x, and that will give us a limit as x approaches 0. We're going to have 1 minus cosine of x divided by x, and also limit as x approaches 0 of 1 plus cosine of x. I just wanted to do this one, splitting it, because I know this is a special limit which always gives us a 0. Whenever we've got 1 minus cos x over x, that is a 0. If we get to substitute 0 here, to be cos of 0 is 1. 1 plus 1 is a 2. And 0 times 2 is still 0. So that is another way you can take it. Want to evaluate the limit as x approaches 0 of tan of x minus sine of x divided by sine cubed x. This is the same as limit as x approaches 0. We're going to have tan of x minus sine of x. I can now write this as 1 divided by sine cubed x. So this will give us a limit as x approaches 0. Tan can be written as sine of x divided by cosine of x minus sine of x, and then multiplied by 1 over sine cubed x. And this will give us a limit as x approaches 0. I can factorize out sine, that will be sine x, and we're going to remain with 1 divided by cosine of x minus 1. And all this is multiplying with 1 over sine cubed x. And from here we can see one sine is going to cancel out with 1 there. That will give us limit as x approaches 0. So that will give us, we can also add this. So that will give us 1 minus cos x divided by cos x multiplied by, this is going to be now 1 divided by sine squared x. Okay. Now from here we are going to get the limit as x approaches 0 of 1 minus cos x divided by cos x multiplied by 1 divided by sine squared. We know that that is the same as 1 minus cos squared x. So this will give us now the limit as x approaches 0 of 1 minus cos x divided by cos x, and then I can factorize out the 1 minus cos squared. That will be 1 plus cos x, and then 1 minus cos x. The 1 minus cos can cancel out there. What are we going to remain with? We'll just remain with the limit as x approaches 0 of 1 divided by cosine of x, and then 1 plus cosine of x. Now I can just go direct and substitute where there is x, put a 0. That will be 1 over cos 0 multiplied by 1 plus cos 0. And we know that cos 0 is a 1, so we're going to have 1 over 1, open brackets 1 plus 1. And this will simply give us 1 divided by 2. Another limit here, evaluate the limit as x approaches 4 minus x divided by the square root of x minus 2. Now for this one, if we get to substitute direct, we're going to get 0 over 0, and we don't want that. So I'm going to conjugate, multiply by the root of x plus 2 on top, also down by the root of x plus 2. I'm multiplying by the conjugate of the denominator. And this is going to give us a limit as x approaches 4. So this 4 is going to multiply everything the other side. That will be 4 root of x plus 8. The negative x will multiply also everything. That will be negative x root of x and negative 2x. In the denominator, whenever you multiply a number by its conjugate, simply get the first number, you square it. So the root of x squared, that will just give you x, minus 2 squared, that is going to give us a 4. And we are going to have the limit as x approaches 4. At this point, what I'm going to do is I'm going to get those with roots and put them together. So if I factorize out a root from these two, I'm going to have the root of x, and then we're going to have 4 minus, what is going to remain here is a minus x. And then here and here we have got a 2 which is common. I'm going to remove it, and we're going to remain with 4 minus x. So 4 will remain here, only x is going to remain there, divided by x minus 4. And this will give us a limit as x approaches 4 of the root of x. I'll put these now which are outside together, because what is inside is also the same. Root of x plus 2, and then we have got 4 minus x. What is in the denominator, I want to write it also in terms of 4 minus x, so I can factorize out a negative, and that will remain now positive 4, and then a negative x. So this and this will cancel, and that is going to give us limit as x approaches 4. So we're going to have now a negative in the denominator, and I can simply put it on top, and we'll just remain with the negative x root x plus a 2. And so what are we going to get? We get just to substitute direct. That will give us negative. Where there is x, we put 4 root 4 plus 2. Root 4 is a 2. 2 plus 2 is a 4 times negative. That will be a negative 4. So that is going to be the limit. Now I've got another one here. Evaluate the limit as x approaches 0. 3x divided by x cubed minus 5x. This is the same as the limit as x approaches 0. The first thing is, when you get to substitute direct 0, what are you going to get? We'll get 0 over 0, and we don't want that. So I'm going to factorize out x on top. We're going to remain with 3, and then in the denominator factorize out x. We're going to remain with x squared minus 5. So this and this cancels. That is going to give us a limit as x approaches 0, or 3 divided by x squared minus 5. Now at this point, what I'm going to do is I'll just put a 0. So this will give us a 3 divided by 0 minus 5. Of course it's 0 squared, and this will simply give us 3 divided by negative 5, where I can put just a negative at that point. Evaluate the limit as x approaches infinity of x plus 5x squared divided by 3x squared plus 4x. Now if we get to substitute direct infinity in this function, we're going to get infinity over infinity. We don't want that. So when it is going towards infinity, what you want to do is make sure that you have got a constant. If you want to have x, x should be down a fraction. I don't mean down the whole fraction, but down a number. So what I'm going to do, I'm going to look at the highest power of x, and that is power 2. I'll divide everything by power 2. So this is limit as x approaches infinity. This one divided by x power 2, that will give us 1 over x. So this is what I want to have, 1 over x. And then 5x squared divided by x squared, we'll just get a 5. Divided by 3x squared divided by x squared, that will just give us a 3. 4x divided by x squared, that will just give us 4 over x. So you can see I only have a constant or x in the denominator. I shouldn't have x alone. So now we can direct substitute where there is x, we put infinity. That will be 1 over infinity plus 5 divided by 3 plus 4 over infinity. Whenever you divide the number by infinity is 0, just like when you divide the number by 0 is infinity. So I'm just going to have 5 on top and also 3 down. Now question number 8, evaluate the limit as x approaches infinity of x squared plus 1 divided by x squared or 3x squared plus 1. So this is another special case, but when you've got a root like this, for this one conjugating will do us no good. So if you have got a root like this, because there's no addition sign, if there was an addition sign, at least I would have thought of conjugating. So what I'm going to do is, inside the brackets, I know that the root of 2 squared is a 2. Therefore, also the root of x squared is x. So because I've got x squared inside, I should think of it in that way. I'm going to factorize out x. So this will give us the limit as x approaches infinity. On top we are going to have x squared plus 1. Down we are going to have x. In the root, I'm going to factorize out x squared. If I factorize out x squared here, I'll remain with 3. If I factorize out x squared here, I'll remain with 1 over x squared. And this will give us limit as x approaches infinity of x squared plus 1 divided by the square root of x squared is x. And that x multiplies with this x. That is going to give us x squared. So we're going to have x squared, and then we have got a root of 3 plus 1 over x squared. And so we are going to have the limit as x approaches infinity. I'm going to factorize also x squared there. So what I'm going to have is, anyway, factorizing out x squared is the same as I'm dividing everything by x squared. Let me factorize out x squared. I'm going to have x squared, and so a 1 is going to remain here. Plus, if I factorize out x squared there, I'm going to have 1 over x squared. So in the denominator I've got x squared, and then the root of 3 plus 1 divided by x squared. This x squared and that x squared cancels out. And so we can direct substitute where there is x, we put infinity. That will be 1 plus 1 divided by infinity squared divided by the square root of 3 plus 1 over infinity squared. A number over infinity, infinity squared, infinity cubed is always 0. So this is a 0, this is a 0. So we can see that our limit is going to be just 1 divided by the root of 3. Another one here, evaluate the limit as x approaches infinity of natural log of 1 plus e to the power 3x divided by x. So for such a case like this one, where you've got natural log and you've got an exponential function, we can use L'Hopital's rule where we get to differentiate. Because if we substitute in direct x there, we're going to have infinity over infinity. Such are cases we want to avoid. So we're going to have the limit as x approaches infinity. And if we get to differentiate this, whenever you are differentiating a natural log, simply differentiate the number which is here and divide by itself. So if we differentiate 1, we'll get a 0. If you differentiate an exponential function where the base is e, simply differentiate the power, the derivative of 3x, that will give you 3, and multiply by this thing itself, that will be e to the power 3x. And then divide by the same thing which you are differentiating, that is the 1 plus e to the power 3x. So I've just differentiated the one on top. If I differentiate x, I'll simply get a 1, so it is as good as not writing it. Well, this is just still a little bit tricky. If we get to substitute again infinity, we'll get infinity over infinity. So I can differentiate it for one more time. until I reach to a constant. So I'll differentiate the power. That is going to give me a 3. And that 3 multiply with the whole function. So that will be 3 times the 3. That is going to give us a 9. That will be 9 e to the power 3x. And then divide. Also differentiate what is here. Now for here, because the natural log already went when we differentiate for the first time, we're not dividing by itself when we differentiate it, because the natural log is no longer there. If we differentiate 1, we get a 0. Differentiate e to the power 3x, we are going to get 3 e to the power 3x. So this and this cancels out. And this will give us a limit as x approaches infinity. 3 into 9, that is going to give us a 3. Therefore, this limit is equal to 3. So the limit of a constant is simply that same constant. And the last question, evaluate the limit as x approaches 2 of x to the power 3 minus 8 divided by x minus 2. If we substitute direct 2 here, we're going to get 0 over 0. We don't want that. So for this one, I can easily factorize. Whenever I've got a difference of 2 cubes, a to the power 3 minus b to the power 3, this always gives you a minus b, and then a squared plus ab plus b squared. And then we'll just get to substitute. Now, 8 can also be written as 2 to the power 3. And so this will give us a limit as x approaches 2. Now our a in this case is x, which is raised to the power 3. Our b is 2, which is raised to the power 3, because 2 to the power 3 is the same as 8. Therefore, this is going to give us x minus 2, and then x squared plus 2x plus 4, divided now by x minus 2. So you can clearly see that these two can be able to cancel out. And what are we going to get? This will give us a limit as x approaches 2 of x squared plus 2x plus 4. And what will this give us? We can now direct substitute. Where there is x, I'm going to put a 2. That will be 2 squared plus 2 multiplied by 2, and then plus a 4. 2 to the power 2, that is a 4. 2 times 2, that is a 4, and then plus a 4. And this is going to give us a 12. Well, and this video ends at this point. If this is going to be helpful, please be sure to subscribe. Enjoy your day.